Okay, we're going to produce a graph given a situation. The situation in this case is a scuba diver going on a dive. Her dive lasts 30 minutes. And it says here that her initial descent took her to a depth of 12 meters, and she achieved this depth at 4 minutes into her dive. Okay. When she reaches that depth of 12 meters, she then stops to equalize her pressure for 4 minutes. So at 12 meters, she stops, and she stays there for 4 minutes. She then continues to descend another 8 meters, in 2 minutes. She maintains this depth for 4 minutes. She then starts her ascent to the surface, which takes 16 minutes. We're going to create a graph that shows the situation. So we can see here that the diver is in the water for a total of 30 minutes. She descends 12 meters and then another 8 meters. So in total, this diver is going down 20 meters. So if we're going to create a graph, we know that our time, whichever axis we graph time on, is going to have to go up to 30, and our depth is going to have to go up to 20. So I have a bit of grid here to talk about this. So we have to figure out, first of all, what is the independent variable and what is the dependent variable. The independent variable in our case here is going to be time. And our dependent variable is the depth, because the depth of her dive depends on how far into the dive she is. So her depth depends on the time. So I'm going to graph my time on my horizontal axis. So this is going to be time in minutes. I want to maximize my space here as much as I can, so I'm probably going to go up by 2s, or maybe even 4s, just to so this is not too jumbled. So I'm going to have 4 minutes here, 8, 12, 16, 20, 24, 28, and 32. So we can see here. So I know my dive does last the 30 minutes, so 30 would be in right here. And then going up the side, I have my depth, which is in meters. So this axis is T, and this axis here is D for depth. So now I just have to remember my situation. Oh, actually, on my depth, I have to make sure I can go up to 20, so I'll probably go by 2s. And that'll, I think, give us just enough room. Yeah. So there's 20. So I have enough space here. I've used my space pretty wisely, I think. So our first part of our dive, it says that she, of course, starts at the surface. She then continues underwater 12 meters, and it takes her 4 minutes to achieve this. Okay. So at 4 minutes, we have a depth of 12 meters. And I'm going to assume a constant rate of descent here. So I'm going to use a straight line, and there it is. Once she hits 12 meters, it says here that she then maintains that depth for 4 minutes. So 4 minutes later, she's still at that depth. Move that up a bit there. Oops. Let's try that again. Okay, there we go. So we see the first part of the graph where she descends 12 meters. She maintains that depth then for 4 minutes. After that, she continues to descend another 8 meters. And if she's already at 12 meters, another 8 meters is going to bring her down to 20 meters underwater. And she did that in only 2 minutes. So 2 minutes later, here at 10, which would be right here on our graph, she is now at her total depth of 10. Total depth of 20 meters. Well, there we go. And then she maintains that for another 4 minutes. Okay, so that'll bring her up to right here, which would be 14. So 14 minutes into her dive, she's still at 20 meters underwater. Okay, so there's that graph. She then continues to go back to the surface. So she turns around, she's going to go back to the surface. Again, we're going to assume at a constant rate, and she's going to travel all the way 20 meters back up in 16 minutes. So that'll give us our 30 meters, or our 30 minutes of time. Okay, so that takes her back to the surface. So we can see here a graph that accurately represents the situation of this diver. The horizontal pieces that we have in our graph right here and here is where she's maintaining her depth. Okay, as she's going down, we have a positive slope going up here, and then she's turning around at this point and going back to the surface